mechanical thermostat with 3 hubs, one on top, other in the middle, other in the bottom. The top one receives the signal in order to select mechanical ventilation or air condition system.
The thing is the remote sensor.
Oh, the remote sensor. Where should be located, Nico?
So the remote sensor, we should really have this somewhere in the flow of the return.
Exactly. Should be located here, no?
We want to be very careful how we can place it here, although we want to make sure the metal bulb aspect of it is not touching the metal.
Not touching the metal, a little separated, no?
We can put it
A plastic or
here.
Exactly.
Sometimes you'll have a return vent. Let me grab a return vent. I'll show you that.
That's the sensor. And this is the sensor that should be located here. Or here, a little separated from the unit.
Yes, this is the sensor, and normally it's located in front of the suction side of the evaporator. Yeah, in that area is the location of the sensor. Now we are going to talk about the digital thermostat. Those thermostats are widely used because they are accurate, and they are once again the sensor connected to the suction side of the evaporator, and the other end of the other cable of the thermostat is connected with the computer, with the circuit board of the air conditioning unit. Okay, we are going to check in the company, in Mauro Power Systems, how the thermostat is operated, how to use the thermostat, and how the efficiency, the consumption in amps of the air conditioning unit increase and decrease when the temperature, the input temperature and the output temperatures are pretty close. The consumption is less, but when we want less temperature in the output in comparison with the input, the consumption in amps increase. And yes, we are going to modify the input and output temperature in the thermostat, and we are going to check the procedure to use the digital thermostat
Properly. Here we have our new color touch display. So when we look at the display, we're going to go up on the temperature. So I'm set right now for 65, so I have a very big difference from the ambient temperature right now to the temperature I'm set for. So I'm going to now go up a little bit, and I'm going to bring this to 75. If we look at the amperage, I've now dropped down to 22.
Yeah, go down. Oh, okay.
So the idea behind this unit is that the unit will almost never be shutting down.
This is another demonstration of efficiency.
Absolutely.
That's perfect. Yeah, we are going to refer to our students. We have basically the same input temperature and the same discharge temperature, and the consumption decreased dramatically.
So now the consumption just went back up because now this return temperature just went up a little bit.
Okay.
So if I put him back up, I'm going to put him a little bit closer. And
the amps start to go down and down.
it's going to take a little bit of time since it just sped back up again. There is some delays. That way the compressor doesn't go.
Yeah, that's correct. Depend on the compressor, of course.
We really don't want to put too much load on our systems. It just dropped down again, so it just had enough time to switch, but we don't want the compressor speeding up and slowing down. It's speeding up and slowing down. We want it to be very uniform.
Correct.